I see Emma already has an answer, and we're going to check if those answers are correct. Thank you. Um, this is just as a quick review because really today I'm starting new material. So let's just go through these examples. I'm going to do number one, and then I'm going to ask for a volunteer to do number two. Somehow, these type of questions of writing the equation of a line causes a lot of problems. So let's see if we can get it clear. We want to write something in the form y equals mx plus b. If we're asked to write the equation of a line, we want to put it in the slope-intercept form. And when we go to write the line, unless it's one of our special lines that are either straight up and down, which we call a vertical line, or straight across a horizontal line, regular slant line. If it's just a regular, if it's a slant line, we want to get something in the form y equals mx plus b, where m is going to be the slope of the line, and the b is going to be the y-intercept. I'm just trying to get this out of the way. So okay. So when I read this equation, it says write the equation of the line through the point 6, -2, and perpendicular to this line 2x plus 3y equals 12. Now, I always want to work on the slope first. We want to try and find out what is the slope first. Notice when we go to graph the line, we actually go to the y-intercept first. But when we want to write the equation of the line, the first thing we want to do is find the slope. And the only clue that I see about finding the slope is that it's telling me that it's perpendicular to the line 2x plus 3y equals 12. Let's call this line, I'll call it line A. Here's my line A. It's 2x plus 3y equals 12. Well, this line isn't in y equals mx plus b form. But I can put this line into y equals mx plus b form by first subtracting 2x from both sides, which will give me 3y equals -2x plus 12. Remember, we always try to put the x term first. And then we're going to divide everything by 3. So if we simplify this, we get that this line is a line y equals -2/3 x, and 12/3 is plus 4. Now, the one thing we're interested about in this line is what is its slope. This is a slope, let's call it slope, and I'll put parentheses to say it's the slope of line A. This is my line that I'm trying to write the formula. They're not necessarily the same slope. The only time they actually are the same slope is when the two lines are parallel, but these are not parallel lines, these are perpendicular lines. So the slope of my original line is the number that's attached to the x, which is -2/3. So the slope of my line, the line that I want to write the equation of, I now can figure it out, because when lines are perpendicular, the slopes are opposite reciprocals. That means I have to flip this over and change its sign. This is -2/3, so the slope of my line is going to be +3/2. So I've accomplished the first part of this. I have found out that the slope of the line that I want to write the equation of is 3 over 2. So now, once I have the slope, I can work on figuring out the y-intercept. And I do that by using the point that they gave me. They gave me a point on the line. The point on the line is 6, -2, which means when the x is 6, the y has to be -2. So I'm going to work my way up here. So I have, in place of y, I have -2 equals 3 over 2, that's my slope, times my x. Now my x I know is 6 for this point, plus b. Now remember what I told you to do. When you have a fraction for your slope, put the number that's next to it over 1 so that you end up with a fraction. And you know, when you're multiplying the fractions, which is the next step you're going to do, you multiply the tops together. 3 times 6 will give you 18, and 2 times 1 will give you 2. So this will end up being -2. This part is 9, because 18 over 2 is 9, plus b. And now I can bring this 9 to the other side. Okay, so I'm erasing this. I'm sorry, I keep erasing things. Not a big blackboard here. And that gives me that the b is equal to -11. So my equation then becomes y equals 3 over 2x minus 11. I see that you have to, okay, MIC, you did get that right, great. Kashira, you have to be careful about getting the B right. You got the right slope, but you didn't get the right y-intercept. Let me mention also, so in terms of getting these type of questions on a midterm or a final, and there always are going to be a question about a parallel line or a perpendicular line. Very often, all you have to do is figure out the right slope, because if you look at the equations, the choices they'll give you, sometimes they give you 2 with the same slope, but they might give you all different slopes. And if you figure out what the right slope is, you don't have to go any further, because that has to be the right answer. We're going to see those type of questions a little bit later. Let's just does anybody have any questions they want to ask me about this question?
I do. I'm trying to see where was my error. Just because she was speaking.
Yeah, I see. Can I go? Should I go back? Do you want me to redo it?
No, that's fine.
Okay. Okay. Would somebody like to Okay, let me see. Um, you know what, Cheryl, I see that you said you're confused. Let's leave this problem for now. And I will come back at the end of the period and I'll do a couple more of this type really slowly. So maybe that'll help you. Okay.
It's not that I'm confused, Professor. I came on late. So
Oh, okay.
that's
All right. So let's not
Oh, I'm
worry about
sorry.
this problem then. Okay. Okay. Um, but are you okay now? Does somebody want to give me, does somebody want to do this example for me? Example number 2. Anybody want to volunteer to walk me through it?
Okay, I'll do it.
Okay, Jennifer, that's you?
Yeah.
Okay, so I'm going to erase everything else so at least we can concentrate on what's on the board.
Professor, I got it. I know what was my error. It
Oh,
was the X and Y when I put the lines.
yeah.
I put -2 for X and 6 for Y. That was my error.
Yeah, I know. You know what? That is, you know what? Sometimes I almost do that because when you see the point, you just right away put them in the order, and the point is the X first and the Y second, but in the equation, the Y is first and the X is second. So you really have to concentrate on that. I've done that myself. I know it, and I don't know any way of remembering, just you have to remember. It's just an easy mistake to make. And unfortunately, the easy mistakes are the ones that the people who make up the multiple choice questions know you're going to make. So they're very often put that answer on. Okay, Jennifer, right? You were going to do this one?
Yeah.
Okay, so I want to, here's my f of x. It's -3x squared minus 15. What should I do to find f of -3?
You have to plug in. You have to plug in -3. That's the -3, right?
Right, that is a -3. Where should I put the -3?
It's gonna be -3 parentheses -3 to the second power minus 15.
Correct. F of -3 means just go to the x and replace it with -3.
So I'm not gonna lie, I plugged this into my calculator.
Okay.
I did -3 times -3.
What did you get in your calculator?
9.
Okay. Let me give you a little hint. If you're doing it in your calculator, you could have just stuck it in like this.
No, I put it all together, but since I'm explaining it, breaking it down, that's why I'm doing it like that.
Okay. So okay. So you did the -3 times -3, and it gave you positive.
9.
Right.
So then you have to do it to the second power. So it's 9 times 9.
Wait. What's the order of operations? What do I do first? Do I multiply first, or do I,
Exponent.
Yes,
or do I do the exponent first?
you exploded.
I have to do the exponent first. So therefore, I have to do the -3 squared, which is -3 times -3. That gives me positive 9.
Okay.
And then what do you do?
Then you have to multiply 9 times -3.
Right now, you're multiplying the -3 times 9, which is giving you,
-27.
right?
Then you have to subtract 15 from -27.
Okay. And what did that get you?
-42.
Right, negative 42 is the correct answer. And you're right, if you could stick it right all into your calculator and it'll come out the right answer. Be careful though, when you're doing it in your head, that you do things in the proper order of operations. Thank you very much, that was good.
No problem.
Okay, so I think we're okay on that. So let me just tell you where we're going from here and what you should be expecting. There is going to be, I haven't made it available yet, but I think it's going to be after, by tomorrow after class. There's going to be another quiz on Delta Math. The quiz will be on what we covered now in chapter 2, which is on the graphing, the types of things that we did on the graphing, everything from the last quiz that we had on Delta Math. Then today we are starting chapter 3. The midterm covers chapters 1 through 4. Today we're going to be starting chapter 3, and we will be finishing chapter 3 next week. After we finish chapter 3, I am going to be giving you a test on Blackboard that is going to be similar to the type of test that you're going to have as a midterm and as a final. In other words, it's going to be a multiple choice test. I want you to get used to doing those type of tests because those are the main tests of the year. The midterm is worth 25% of your mark. The final is worth 35% of your mark. So those are biggies. So you have to be familiar with how to take that type of test. So after we finish chapter 3, instead of having another quiz on Delta Math, what we will have at that point is a test on Blackboard. So where are we now? Let me just reiterate this. There is going to be a test made available for you, a quiz on Delta Math starting tomorrow. I would like to give the due date as Tuesday. Is that too early for anybody? Can we set it for Tuesday?
Yes.
No objections. Okay, so I think we're okay. As a review for that quiz tomorrow, Melissa is going to be taking over our class tomorrow and doing a review of that for that material. So tomorrow is going to be totally review for that quiz. Even though we've been doing a lot of review, she is going to review for that quiz with you. Okay. And of course, this is aside from, she's doing this aside from her regular tutoring hours. She's taking over the class for us, for which I am very grateful. And I happen to like what I see her doing. Let me just, there was something else I wanted to mention. Of course, I've forgotten it right now. But yes, I did want to mention that when I look over the records on the Delta Math for our class, I see most of the people are keeping current with the assignments and with the quiz. If you are behind and you find that you are locked out of something and you cannot do it and you want to do it, just send me an email. Does everybody know my email address? You should, because it comes up because I'm emailing you all the time. But email me if you need anything opened up Or if you weren't happy, let's, uh, on the homeworks, it doesn't matter what mark you get it on it. It just has to be done. If I see that you've worked on it, you get it as a complete homework mark. But the quiz, actually, the mark really counts. Now, if you're really not happy with your quiz mark, you could, and you would like to retake the quiz, again, send me an email and I can reset. I have the ability to reset things and redo them. So just let me know if you have any problem running into those type of things. Just email me and keep in touch. Okay. So as I said, today we are going to be starting on a new topic, which is not totally new. It really flows very much from what we've been doing in chapter 2, because chapter 3 also has to do with linear equations and graphs of linear equations. But what we're going to be doing today is what's called solving systems of equations. Now, when you talk about a system of equations, what you're talking about is you don't have just one equation that you're dealing with. You actually have two equations. And when we want to solve a system of equations, we want to find what happens when we draw two lines. Let's think about what could happen, and then we'll talk about how we go about and do what this process is called solving. Now, first of all, I'm just doing a theoretical understanding of what's going on, and then we'll do an actual problem. So in a system of equations, I'm going to have two equations representing two lines. Let's think what could happen when I graph two lines on the same set of axes. Well, let's say this is our first line. Let's call this L1. And this is my second line, L2. Well, when you draw two lines on a graph, on the same piece of graph paper, one of the most common things that can happen is that those two lines meet. They intersect. They cross each other. That's the most common situation. Now we know when they're straight lines, once they cross each other, they can't cross each other in any more than one point. They can cross at exactly one point. And if we can find what that point is, let's call that point, that's the XY of that point. The X is the X coordinate of the point of intersection, and the Y is the Y coordinate of the intersection. Let's say it's 4, 1 or something like that. That is what's called the solution of the system of equations. So when we go to solve a system of equations, what we're going to be looking for is where the two lines meet. So the term is going to be a system of equations, but the actual work that we're doing is trying to find where the 2 points meet. How we do it, we're going to work on how to do it, but we want to know what we want to do before we actually do it. This is also, the terminology is, this is called a consistent system of equations. Now, if you think about it, something else might have happened when you draw two lines on the graph. Let's say this is line 1, and this one is line 2. And these two lines, no matter how far you extend them, do not meet. What do we call those type of lines? parallel lines. We have two parallel lines. Well, if they don't meet, then there's no solution. Because the solution means, where are they meeting? If they don't meet, then they don't have a solution. Sometimes we also use this symbol, the zero with a line through it, to indicate no solution. This type of system equations is called an inconsistent system of equations. Because there is no solution. And actually, even when you look at the equations, even before you go to graph it, you should be able to tell that you're going to have an inconsistent system of equations, because if the lines are parallel, then we know that the slopes are going to be the exact same numbers. So anytime I give you two equations that have the same slope, but different y-intercepts, are going to be parallel, and you're not going to be able to find a point of intersection. There actually happens to
Can you
be
repeat that?
a
Can you repeat the
third
last part again? I'm sorry.
question.
Yeah, Jonathan, by the way, I'm sorry. Good morning. You said if they have the same slope but different y-intercepts, they
Right.
won't cross, so it'd be considered inconsistent?
Yes,
Okay, thanks.
exactly what I said. I think you said exactly every word that I said. That was perfect.
Oh, okay.
Okay. So sometimes we have consistent systems of equations. Sometimes we have inconsistent systems of equations. There actually is one other type of equation, a system. I take my first line and I draw it. Let's see, here's line 1. And then I go and I draw line 2. And it turns out when I draw line 2, it comes out right on top of line 1. In other words, line 1 and line 2, even though they didn't look exactly alike to start out with, turned out to be exactly the same line. In that case, this is called a dependent system of equations. Because really, one equation depends on the other. They're really the same equation. They looked a little bit different before you started working with them, but they're really the same equation. And in that case, you have an infinite number of solutions, because there are an infinite number of points on the line. Every point on the line is going to be a solution for both of them. That's a very uncommon situation, but that sometimes happens. So we have these 3 different types of systems of equations. A consistent one where the lines meet in exactly one point. And when we ask for the solution, we need what is that one point where they meet. Or we have parallel lines, so we have an inconsistent system of the equations, and there's no point where they meet, they have no solution. Or when the 2 lines actually are just one, and then you have a dependent system of equations with an infinite number of solutions. So this is what we're looking at. The question is, how do we go about solving a system of equations? That's what we're really looking at now. So I'm going to do one, and then I'm going to give you a few minutes to try another one. Okay? So here's my system of equations, my first system of equations. My first equation is 3x minus 2y equals 6. That's equation number 1 in the system. And my second equation is x minus y equals 1. My second equation in this system. To solve this system of equations, because that's what it is, solve the system of equations. So what do we have to do? So what we do is, if we want to solve this, what's called graphically, we draw the graph of each lines on the same piece of graph paper. Now, I don't have graph paper, but you should be doing this on graph paper. So let's talk about line 1. Let's remember, how do we graph an equation like 3x minus 2y equals 6? So my preference is to find the y equals mx plus b form of the line. So I'm going to subtract 3x from both sides. That'll give me negative 2y, this cancels out, equals negative 3x plus 6. And then, of course, I have to divide everything by negative 2. So therefore, this gives me that my y is negative 3 over negative 2. Now remember, when we have a negative over a negative, we make it positive. So it's 3 over 2x. And 6 divided by negative 2 is minus 3. So now I can use this to draw it. I know the slope of the line, the rise over the run, is 3 over 2. The y-intercept is negative 3. So let's go over here. Here's my piece of graph paper. And let's graph that line. Remember how we graph a line? When we're going to do the graph, we always start at the y-intercept, which in this case is negative 3. So we go down 3. And then, since my slope is 3 over 2, from here we rise 3, go up 3, 1, 2, 3, run 2, 1, 2. Or if I had wanted to, I could have gone down 3. I could have done negative 3 over negative 2, which would mean go down 3 and 2 to the right, to the left. And you draw your line. Now you have to do this pretty carefully, because it's not just a sketch. You really should be doing this on a piece of graph paper. Okay, we have now drawn line 1. We then go and take line 2. Here's line 2. I totally ignore what I did before. I go to equation number 2. And equation number 2 is x minus y equals 1, which tells me that if I want to put this in the y equals mx plus b form, I have to subtract my x from both sides, which will give me negative y equals negative x plus 1. And I'm not finished, because there's a negative in front of the y, which means the coefficient of y is negative 1. So I have to divide everything by negative 1, which ends up giving me y equals, well, negative over negative is positive, so it's positive x, and 1 divided by minus 1 is 1. So for this particular equation, the slope is the number in front of the x. There's no number in front of the x, which means it must be 1, which we write as 1 over 1. Remember, we like to write the slope as a fraction when we're using it to graph. And the B, the y-intercept, is -1. So for line 2, I have to start at the B being -1, which is right here. And my slope is 1, which means I go up 1 over 1, up 1 over 1. Oh, I don't think, let me see. Up 1 over. This is the problem I'm running into. 1, 2. Okay, let's do this. Up 1 over 1, up 1 over 1, up 1 over 1. Looks like it's about here. If I had a piece of graph paper, this would have worked out much nicer. It looks like it's about over here, which means this line looks like this. Here's line 2. And these two lines look like they meet. It looks like this is a consistent system of equations. And actually, I did know that was going to happen because the slope on my first line was 3 over 2, and the slope on my second line was 1 over 1. They don't have the same slope, so they can't be parallel, so they've got to meet. Okay, now here comes the crunch. How do we figure out what this point is? Now, if you were doing this on Delta Math, you wouldn't have a problem because when you click the points, it would be very easy to see on the graph paper. If you're doing it on a piece of graph paper, it's going to work out very nice. This is that's why we have a problem with this, because I don't have real graph paper. But it looks like I have, if I'm this point, I go over 1, 2, 3, 4. So it's 4 to the right. And then it looks like we're going up 1, 2, 3. Did anybody do this on graph paper with me?
I did, but when I did the first one, the first 3x minus 2y, it came out perfectly fine on the graph paper. But then when I plugged in the 1 and 1, the -1 and the m1,
Right.
go up 1, right 1, I went up 1, right 1. So do I, from the second point after I hit that, when it hits the x-axis, do I go up 1, right 1 again from it?
Right. Keep doing that.
From
Up
the
1
same point.
over 1, up 1 over 1. You keep doing it
From
until
each point that I get, I just keep doing it, keep following it from there.
and you could have also, if you wanted to, gone down 1 over 1 to the left. In other words, this just, when the points are so close together, I really like to do more points.
Okay.
Did it meet at 4, 3?
I'm gonna finish. I'm gonna start doing the other one, keep going, and then see where they meet.
Okay. How could I tell if 4, 3 is actually a solution to this system of equations? So, oh, great. Emma got that point. I could check my solution by saying that 4, 3 is the solution, is saying that the x is 4 and the y is 3. And this point, this 4, 3, has to work in both equations because it has to be a solution for both. So checking in equation number 1, replacing the x with 4, I'll get 3 times 4 minus 2. I'm replacing the y with 3, will give me 12 minus 6, which is 6. So that checks. And trying to check it in number 2, I'm gonna again replace the X with 4 and the Y with 3, and I get 4 minus 3 is 1, so that also checks. So it checks in both equations means it's a solution. In order for it to be a solution to the system of equations, the answer has to check in both equations. And you can write your answer either in parentheses 4 comma 3, or you could write it separately, x equals 4, y equals 3. Remember, the first number is always the x, the second number is always the y. So let's just.
I have a question. I'm sorry. This is Jonathan again. So in Delta Math, how would we write this? We'll just put x equals so and so, y equals so and so, or
Okay, if they ask you to do it graphically, what you'd have to do is you'd have to, and then you remember how, I don't know if you, did you ever do graphing on Delta Math? You click on your y-intercept, then you go to another point. You, let's say you go up 1 over 1 and you click over here. And once you click on 2 points, the line automatically draws.
Okay.
And you do that for the second line, and then you'll see where the two meet.
All right. Thank you.
Okay, I'm going to give you one to try now on your own. And while you're doing that, I'm going to take attendance. And then we're going to talk about another way of doing this, because this is really cumbersome. Look at how much room it took. And I wasn't even sure I was getting the right answer because my picture has to be really perfect. Okay, but let's do one graphically. Again, it'll be good if you have a piece of graph paper, but if you don't, fine. Let me try one that's not going to be too hard to graph. Okay. Here are my here's my system of equations. New system of equations. Line 1 has the equation 3x plus 3y equals -2. Well, let's make it like -6. And the other one is y, here's equation number 2, y equals -x plus 4. Okay, see if you can solve that system of equations. I'm going to erase this. I'm going to take attendance while you're doing that. And the first thing I would want to do is put the equations in y equals mx plus b form. Does anybody want to tell me what they got when they put 3x plus 3y equals -6 in y equals mx plus b form? Anybody want to?
I got y equals -1 x minus 2.
Okay, how did you do that, Jonathan?
I subtracted 3x on both sides.
Okay. So you brought the 3x to the other side.
Yeah. And then I got 3y equals -3x minus 6. Then I divided by 3.
Right, everything by 3.
Then be y equals to -3 divided by 3 is -1. So the and then -6 divided by 3 is -2. Yeah.
Okay. So what did that show you?
They both have the same slope.
Right. The slope on this line, there's no number in front of it, says 9 minus x. So the slope is -1, or if you want to write -1 over 1. The slope on this line is also -1. So what does that mean about the two lines, Jonathan? When they have the same, what does that tell us if the lines have the same slope?
That they're parallel?
Yes, the lines are parallel. So what does that tell you about the system of equations? What's the solution of that system of equations?
They're going to be the same?
If it's parallel, there's no solution.
There's no solution. When the lines are parallel, there's no solution.
Can we talk about the like,
What?
how would you graph that y-intercept?
Which one? The first one? This one?
The fraction, yeah.
Okay.
Like, is that important? That threw me off a lot, like having to write like I just kind of put it in, but yeah, I don't know.
Okay. So if I went to this, here my slope we said is -1, which means it's -1 over 1. And my b is -2.
Oh, it's -2, okay.
And then you would have to, from there, go down 1 to the right, or up 1 to the left, and you get a line that looks like this. And the other one happens to go through 4.
Yeah, I think I must have done the first one wrong because my b was like -2 over 3.
Okay.
So
Yeah.
that's why.
Number 1. The first thing you want to look at when you put them in the y equals mx plus b form, you want to see if they have the same slope, because then the y-intercept doesn't
matter. That makes sense.
number for the y-intercept as well. If they come out to be the exact same equation, then you know it's dependent. But if they just have the same slope but different numbers attached, then you know there's parallel and the system is inconsistent. Okay. And it doesn't matter if this turned out to be a fraction or not. Do not worry about lines that have, I really should show you how you would graph a line that has a y-intercept that's a fraction. What you'd have to do is find some other point on the line that's not a fraction, and then use that as your starting point. But when we graph it, we really usually just use the y-intercept. That would be the case you'd have to do. Don't worry about that. You're not going to have that problem. Okay? All right. Now, what happened here is that we were able to solve this, so to speak, by saying we don't have a solution. What I want to do is show you an alternate method to solving these systems of equations that don't involve graphing. You'll see when we do it by this alternate method, and there's more than one, we won't have to graph. So that'll be a lot quicker because graphing takes time. And it'll be more accurate because, as you notice, my graphs aren't terribly accurate, especially if I'm not doing it on graph paper. But even if you're doing it on graph paper, if the points don't meet right on a box, but they meet in the middle of the box, you're not going to know if the answer should be 3/2 or 3/4. It's going to be very hard to tell fractions or decimals or anything like that just from graphing. So I'm going to go back and show you an example where I'm going to solve this system of equations without graphing it, but I'll still be able to find a place where the two lines meet. Let's start with one that's a little simpler, and then we'll come back and I'll show you how it applies to these problems. But let's start with a really simple example. Let's say I have this equation. The first equation that I have is x minus y equals 4. And my second equation that they're giving me is 2x plus y equals 8. Okay, so this is definitely a system of equations. Notice most of the time when they're giving these systems of equations, they're not giving sometimes they do, but most of the time they don't give the answer, the questions in y equals mx plus b form. They usually give it in what we call the standard form, where they have the x, then the y, then the equal and the number. Both of these equations are in standard form. If we wanted to solve this graphically, we would have put both of these, each of these into the y equals mx plus b form, and then we would have that graph the two lines and see where they meet. Okay, I am going to do this by a method that's called, it's an algebraic method. It doesn't involve any graphing, and the method is called the method of elimination. Hope I'm spelling this right. Elimination. And you know what the word eliminate means? It means get rid of. What we're going to look is, we're going to take our two equations and we're going to add, sometimes this is also called the addition method, because that's what we do. Some books call it the elimination method, some books call it the addition method. We're going to take our two equations and we're going to add them. Okay, I'm going to erase these words because then I can work on it. Now let's see what happens when I add these two equations. I can do this because they're all arranged in order. First the x's, then the y, then the equal signs, then the numbers. So when I add the x and the 2x, well, x plus 2x is 3x. What happens when I add negative y plus y? What happens there? Well, the y's get eliminated. The y's cancel out because this is a negative 1y and this is a positive 1y. When you add a negative 1 and a positive 1, you just get 0. So I have 0y, which means I don't have any y's. So I go to the next thing. Just bring down my equal sign. It should be, again, they all have to be arranged under each other. And then I get 4 plus 8 is 12. Since this was equal to this, and this was equal to this, when we add them, we get equal things also. Now you'll understand why this method is called the elimination method. Because by adding the two equations down, what happened is I got rid of one of my variables. I happened to eliminate the y variable. And now I only have an equation with one variable. I have 3x equals 12. Well, that's easy to solve. I'll just divide both sides by
4.
3, and it'll give me that the x is 4. Now, I haven't finished solving this, because when I'm solving a system of equations, I can't just give you the value for x. I have to give you the value of x and y, because really what I'm finding is a point where they meet. So how do I go back to figure out what the y is? I take either one of the equations. Let's say take equation 2. You can take either one, it doesn't matter. And since I now know what my x value is, I'll replace the x with 4. That'll give me 2. Here's my x is now 4 plus y equals 8. And that gives me an equation that now only has y's. It doesn't have any x's. 2 times 4 is 8. So I have 8 plus y equals 8. And I bring this 8 to the other side. It gives me y equals, well, what happens when we have 8 minus 8? The 8's cancel out and I'm just left with 0. So my solution to this equation is, system of equations is x equals 4, y equals 0. Or if you want to put it as a point, 4 comma 0. Remember, you always have to put the x first and the y second. And notice
Wait, Professor, I have a question.
Yeah, I'm so lost.
Yeah,
Okay, so this system of elimination method of elimination, we can use to find the solution to the other problems that we did. It's the same exact thing, but just a different process of elimination.
it's a different process. It's an entirely, this is what's called an algebraic process because we're just working with numbers. We're not
This
doing
will
anything.
give us this will give us the value of x and y
But
and
it
give us a
it
point.
is the exact same thing that if we would have graphed each of these, we would have gotten it on the picture.
So
So
it's
we
kind
can
of
use
okay if you don't get it. Sorry.
That's the same answer. Now,
Okay.
which method looked easier to you?
Which one? I'm sorry.
Which method looked easier?
This one is so much easier for me.
This looks much quicker and easier.
Yeah.
It
And
really
it gives you the point so that you don't have to look for it on the graph on your own. You just
right, and you don't have
solve it to get it.
and make mistakes on your graph
Yeah,
because
it's so
that's
much
your,
better.
I don't get this one yet.
okay.
Yeah.
All right, I'm gonna go through the steps again.
Okay.
And then I'm gonna do another one. All I did was I started with the two equations and I just added them. So let's, again, look what happens when we add. I have that's why it's nice that it's arranged in order because I have the x's under the x's. So I have, this is a 1x plus a 2x. So that gave me 3x, correct?
Mm-hmm.
Then I had, the next step I had was negative y plus y. Now what happens when you add negative y plus y?
It's 0.
You get just 0. You want me to
So
put it?
that's how we find the x. That's how we find the x of
Right.
the point. Okay. And then the second
We're
step is
okay
finding the
with
y.
Find the x.
I get how to find the x, yeah.
Okay. When you want to find, once you have a value, and it could be either the x or the y, it doesn't matter. Once you have a value for, let's say, the x,
Mm-hmm.
you take either one of the equations, and I'm now going to do it. I happen to have taken equation 2. I could have taken equation 1. Look at what would have happened if I replaced the x in equation 1 with 4.
Mm-hmm.
That would have given me 4 minus y equals 4. Now I want to figure out what y is. What should I do?
You gotta get rid of that 4 on the left side.
Right, so you get rid of this 4, so I'm going to subtract 4 from both sides.
And that means y equals 0. There we go. Okay, I think I do get it now.
Negative y equals 0.
Yeah.
And then, of course, you're really supposed to divide by negative 1.
But it's 0. Yeah.
And there you are. So once you have one, they have to get a different marker, sorry. I'm just looking for a different marker so it comes out darker. Sorry, I have to opening up this package.
So 1 and 2 are line 1 and line 2.
This was line 1 and this.
Uh-huh. Okay.
And notice it didn't make a difference which of the lines, which of the equations I used to find the y. Because you get,
But don't we need to find the slope?
notice, since we're not graphing it, we don't have to find the slope, no. Because we're doing it in an entirely different method. We'd have to find the slope if we wanted to graph it. Since we weren't graphing it, we didn't have a problem. We didn't have to find the slope.
Oh, because all we're trying to figure out is where the lines meet.
Right.
Okay, I get it. I fully get it, I think.
What's interesting, if you think about it, I didn't do any graphing, but I
Mhm.
found a point where the lines meet. I did it what's called algebraically, which is a more accurate and quicker method, but it gives you the same results. It tells you the system of equations where the solution to the system of equations, which is where the lines meet. Now let's try another one. I'm going to give you one to try on your own, and then we'll do one that's a little more difficult.
Professor,
Yes.
can we try? Well, go ahead. Let me see what you're gonna do first, and then I'll tell you.
Okay. Um, Here's my first equation. 2x minus y equals -2. And -2x minus y equals +2. Okay, here's equation number 1. Here's equation number 2. Do you want to try it on your own?
Yeah.
Okay, so let me give you a few minutes to try it. We finished. Let's add the equations together. So in the first case, we get 2x.
Oh no.
Are you okay?
When we add this,
Coughing in the class. I need some water. Yeah, okay.
Yeah, he told me having no time. Like they kicked me out, don't cry. So
okay, just trying to mute it so because there's outside noise. Okay, here it says we have a 2x and a -2x. So when we add 2 and -2, we get 0. So this is 0x. The x's actually cancel out. The next we have our y's. We have a -y and a -y. Now notice those are not going to cancel out because this is like adding a -1 and a -1. When you add -1 plus -1, you get -2. So this is -2y. And over here on the other side of the equation, we get -2 plus 2. And that does cancel out. That gives us 0. Notice I could have put in the 0 for over here, but it's not necessary because I have other things going on. So here's where you're going to have to be very careful with your additions, etc. I just want to finish this up by figuring out what y is. In this case, when since it says -2y, I'm going to divide both sides by -2. And 0 divided by any number is 0. It turns out that the y equals to 0. And now we do what we did before. We now have the y. In the other case, we got the x. Sometimes we get the x, sometimes we got the y. Let's take our first equation and replace the y with 0. So then I'll have 2x. Now, in place of y, I'm putting 0, so it's -0 equals -2. So 2x minus 0 is simply 2x. So we get 2x equals -2. And when I divide both sides by 2, I get x equals -1. So now I know my solution is y is 0 and x is -1. It is a consistent system of equation, and the point of intersection, remember, I always have to put the x number first, is the point -1, 0. Is that clear? Any questions about that? If not, I want to do another problem. Okay, here's another system of equations. The first equation they gave me is the equation 2x plus y equals 3. The second equation they gave me is 3x plus 2y equals 1. It is, again, both of the equations are in standard form. They seem to be set up perfectly for me to do the elimination method. So let's add these two equations down. When I add 2x plus 3x, I get 5x. And when I add y plus 2y, I get 3y. And that equals 4. Does anybody see a problem with this? What happened here? Is this what I wanted to get?
No.
Why not? What didn't happen?
We can't solve for one of them? I don't know.
Right, we didn't eliminate either an x or a y. All I got was another equation with x's and y's. And you know what? It's very likely that that could happen. Who says every time you add two equations down, one of the variables is going to be eliminated? So obviously that method is not working for this system of equations. Well, I'm going to show you a way of forcing this into working. Can I get the elimination method to work? So here's what I'm going to do. I think, what made the variables eliminated? Why did the x's over here disappear? Well, it was clear that they had the numbers in front of the x's were the same, except one was positive and one was negative. When you add two numbers that are exactly the same, except with opposite signs, you'll always get 0. So here's what I do. I look at the equations and I say, okay, I'm going to decide to eliminate one of these variables. Anybody want to give me which variable I want to eliminate?
Does it matter which one you eliminate?
No, it does not. Should
Okay, so let's get rid of the x.
Okay, let's try to get rid of the x. So if we want to get rid of the x's, we want to end up with the number in front of the x's to be the same number, except one should be positive and one should be negative. So what I do is, and this is not always doesn't always give you the easiest numbers, but it's the easiest method to remember. Take each equation and multiply it by the coefficient of this second equation. In other words, the first equation, I'm going to multiply the x by 3. Why am I doing by 3? Because I want to get rid of the x's. And the second equation, I multiply by the coefficient of the first equation. So I multiply them by their opposite numbers. That means I take the 3 and multiply the top by it because I'm looking at the x's. And the bottom, I'm multiplying by the 2. But before I do the multiplication, that'll mean they both come out to be the same numbers, right? But I want one to be positive and one to be negative. So therefore, I'm going to use a negative sign with one of them. And it doesn't matter if I multiply the top equation by the negative or the bottom.
Wait, I'm sorry, man. I'm sorry. Why did you make it a negative? I'm sorry.
You have to speak louder. I'm not hearing you clearly.
Why did you turn the 2 into a negative 2?
Because I want to end up with a number in front of the x's being the same number, but one has to be positive and one has to be negative in order so that when I add them, they will cancel out.
Oh, okay.
Just keep in mind what we're trying to accomplish. So if I multiply my first equation by 3, and I have to multiply everything, not just the x's, but everything by 3, I'll get the equation 6x plus 3y equals 9. Don't forget to multiply on the other side of the equation as well. As soon as you multiply everything, it's like using the distributive law. You're just doing everything.
Professor,
Yes. Kachira?
can either equation be... Wait, why is it echoing?
Choices. You got to turn one down. Let me finish this one and then I'll answer any questions, okay? Multiplying the second equation by the negative 2 will give me negative 2 times 3x is negative 6x. Negative 2 times 2y is negative 4y. And negative 2 times 1 is negative 2. And now look what happens when I add these two equations down. The 6x and the negative 6x are going to come out to be 0. They cancel out. That's what I'm trying to get. I'm trying to eliminate one of the variables. And I specifically picked the x to eliminate. I could pick either the x or the y. It's totally irrelevant. But once I make a pick, I do multiply by the numbers based on the x's because that's what I picked to get rid of. In terms of the y, this is a positive 3y and a negative 4y. When I add a 3 and a negative 4, I get negative 1y. And on the other side, I get 7 and plus negative 9 plus negative 2, which gives me 7. And then I'll divide both sides by negative 1, which will give me that the y is equal to 7. By using multiplication, I was able to get the two coefficients of the x's to be the same number with opposite signs. And that meant that when I added them, they disappeared.
Mrs. Pim, Pim.
Yes.
Y equals minus 7, negative 7. It's not 7.
Oh, you're right, because thank you. 7 divided by negative 1 is negative 7. Zia, it's a good thing I have you here to keep me on the straight and narrow. Okay, this one we did already, so I can erase this. Once I have what one of the variables are, in this case, we figured out what the y is, I can go back and I go back to either one of the original equations. Let's take the original equation number 1, which was 2x plus y equals 3. And now replace the y. Now I know what the y is. So I'm going to replace the y with -7. So I'll get 2x. This becomes -7 equals 3. And now all I have to do is figure out the x by adding 7 to both sides. This will give me 2x equals 10. And therefore x equals 5. So the solution to this system of equations is x is 5, y is -7. So even if, when we originally add the two equations down, we don't get rid of one of the variables, we still have options. If they don't, if the two, if either the x's or the y's don't have the same coefficient, the same number in front of them with opposite signs, then we just multiply each equation by the opposite coefficient, and that way it'll get rid of our
Excuse me,
x. Yes.
it's Jennifer. I have a question. Okay, so in the second equation that you just did on the left hand side, you plugged in the -7 into that just to check it to get the point, right?
Right.
So you could use this -7 on either or of the
Either
equation.
equation, and guess what? You'll get the exact same answer.
Okay, okay.
That's what the beauty of this system. It doesn't matter. You really have a lot of choices as to what to do, but even when you do it, you'll come out with the same result. Okay, do you think we have time to try one more? It looks like we're almost at the end of the class, so instead of giving you a chance, this is where we'll start out on Tuesday next time. But let me do one more example like this just to get it, to click it in. Okay, so I'm going to write another equation. Can I erase this?
Yeah.
Yeah, go ahead.
Okay, so let's say I have this system of equations. 3x minus y equals 7, and 10x minus 5y equals 25. Okay, and again, I think if you look at it, you'll see if you add them down, the 3x and the 10x will give you 13x. We're not getting rid of that. And the -y and the -5y give you -6y. So just adding the equations without multiplying is not going to be a help. You will not eliminate one of the variables. So let's decide, what do we want to get rid of? Do we want to get rid of the x's, or do we want to get rid of the y's? Anybody have any?
Let's get rid of the y.
Okay, you want to get rid of the y's this time? Okay. So now remember, when I'm picking the numbers, now here's what I just look at the numbers. This is understood. In front of the y, there's a -1. Don't worry about the negative. First, worry about the number. So the top equation, I'll multiply by the 5. Remember, I'm just looking at the number. I'm not looking at the sign. The sign I deal with differently. The second equation, I'll multiply by the 1. Okay, so I multiply them by their opposite coefficients. Remembering, don't bother about the negative signs. Don't worry about the negative signs. But before you do the multiplication, just look. Do the two numbers have the same sign, or do they have the different signs?
Same sign.
They have the same signs. Do we want them to have the same sign?
No.
No, we need them to have opposite signs. If one would have been positive and one would have been negative, that would have been perfect. That's what I want. But in this case, they're both negative. I need one of them to become positive. So I have to take one of the numbers that I'm multiplying by and make it negative. Should I make the 5 the negative or the 1 the negative?
Does it matter?
No?
The 1.
Okay. Okay, so let's remember how we made this decision. First, we look at the numbers, don't care about the signs, and pick the number from the bottom to multiply the top, pick the number from the top to multiply the bottom. Then, before you do the multiplication, look at the signs. If the two signs are the same, you're going to have to use a negative in one of them, so that you end up with one being positive and one being negative. If one sign is positive and one is negative already, then you don't have to worry about the signs and you just use the positive numbers. Okay, so let's go on from here. Multiplying that top equation by 5 will give me 15x minus 5y, because negative 1 times 5 is 5, and 5 times 7 is 35. I multiplied every single term by 5. In my second equation, I'm multiplying everything by negative 1. So negative 1 times 10x is negative 10x. Negative 1 times negative 5y is positive 5y. And negative 1 times 25 is negative 25. And I'll know I'm on the right track. Remember, I decided it was the y's that I wanted to get rid of. And I look at the numbers in front of the y's, they're both 5's, but one is positive and one is negative. That will mean when I add, the y's will be eliminated. So now I add the two equations. 15x and negative 10x gives me positive 5x. Negative 5y and positive 5y, when I add them, give me 0. They just disappear. And 35 plus negative 25 is 10. And now I have an equation that just has x in it. So I'm going to divide both sides by 5. And that'll give me x equals 2. And now that I know that the x equals 2, I can use either one of the equations. Let's use this equation just to show it doesn't make a difference. Either one of the equations to find the y. If I'm using this equation, I'm going 10 times 2, because my x is 2, minus 5y equals 25. And 10 times 2 is 20. So 20 minus 5y equals 25. And I'll bring the 20 to the other side, which will give me negative 5y equals 25 minus 20 is 5. And when I divide both sides by negative 5, I get 5 divided by negative 5 is negative 1. So my solution becomes x is 2, y is negative 1. Again, we use the elimination method. We just had to do this one extra step of multiplying the equations. Okay, I am not giving you homework on this yet. We have to do more work on this before we but tomorrow after class, there will be a quiz number 2 available on Delta Math. And tomorrow, Melissa is taking over the class and she's reviewing for that quiz. That's what's going to be. Make sure you try and do all the homeworks that have been assigned so that you know what your questions are going to be for tomorrow's review class.
Professor.
Yes.
So the quiz is going to be on perpendicular parallel lines and this.
Graphing of lines and writing equations of lines and parallel lines and perpendicular lines and vertical lines and horizontal lines. All the things that you were on the last on the homeworks from the last 3 times.
Okay.
Also,
And this will be on it too?
no, this is not on it. We haven't done enough of this for you to have a test on this.
Okay.
When we finish this course, well, this chapter, then there's going to be a test on all 3 chapters. You'll tell me if you prefer a quiz just on this and then a test. We'll talk about that next week. What I do want to do is I'm going to be reviewing everybody's record, what they've done on Delta Math. I will be probably sending you out an email sometime either over the weekend or the beginning of next week, telling you where you stand at this point in the course. Are you up to date with what you're up to date? I will, since it's not, we don't have these huge classes, I can do this. And I'll give you an idea of where you stand at this point. Though most people probably know where they are. Don't forget to sign in tomorrow with our new Zoom. I guess it did work. Somehow the new passcode, we didn't have any unwelcome visitors today. Any questions anybody wants to ask me? Okay, I see Azia is helping. Have a great day. And as I said, I'm not going to be here tomorrow. Melissa's taking over.
Professor, remember, don't turn off the Zoom. I'm staying 1 hour on that.
I should leave the Zoom on. Okay.
Yeah.
You should give extra credit to Azia, because Zia be helping us in that chat. Like, she be helping us with the math homework. When we're all stuck, we're in the WhatsApp chat, and she helps all of us. She needs
Well,
extra credit.
You know what? I should give all of you extra credit, and I will, and her extra credit, because you're working on this, and this is a class that's really working, and I see it. The truth is, I'm going slower than I would in another class, because if they don't ask questions, I can go faster, but I prefer going slower and getting people to understand what's, and I see that people are really working on this, and I'm really impressed with the class and all the people that are here. Okay, so I am going to, do you want me to leave the recording on, Melissa, or not?
You can leave the recording, because some students like when I break it down and they would like the recording.
Okay.
Last class I did record it. I just don't know where it went. I think it went to your cloud.
It went to me, and I'm going to post it. You know what? So then I'm going to turn off my recording, and then you can do another recording, and then I can post it as the recording of the tutoring.
Okay.
Does that make sense to you?
Yeah.
Okay. All right.